This video is going to be the part of the lesson 16, and I'm going to solve again quadratic inequalities. So in this video I'm going to only solve the quadratic inequalities. Here firstly I'm going to send, if you remember, in the first step I'm going to collect the terms to one side, then I'm going to find the roots of it. First I'm rewriting the equation here. 0 is greater or equal to x squared minus 3x plus 4. It's going to be, this is the first one, minus 4 actually, it's going to be minus 4, it's going to be. Then we are going to find the function where it is less than 0. For finding this one, firstly I need to find x1 and x2. If you remember, for this one I'm going to write x squared minus 3x minus 4 is equal to 0. This is the quadratic solution method. X minus 4 and plus 1 it's going to be, because the sum is equal to minus 3 and the product is minus 4. This factorization is true. Minus 4 and minus 4x, it's going to be equal to, and here it's going to be equal to x. The sum is minus 3x, which is the midterm. Factorization is true. It means that x minus 4 times x plus 1 is equal to 0, x1 is equal to 4, and x2 is equal to minus 1. It's going to be. These are the roots of the quadratic equation. If you remember this one, here the table I'm going to draw, this is the minus infinity side, this is the plus infinity side. X squared minus 3x minus 4, it's going to be here. The roots are minus 1 with respect to order I'm writing. In a root number line, minus 1 firstly, then 4 it must be. Then, with respect to signs of the x squared, I'm defining the sign of this interval, first interval. First interval, it's going to be plus because this is plus. Then it's going to be minus because it goes in order, plus, minus order, it's going to continue. Then it's going to be plus again. But this time in this question I'm going to shade the negative area because we are looking for less or equal to 0. This is less than 0. This interval is greater than 0. So here this one is our solution set, and here in this interval minus 1 and 4 it's going to be, and we are going to close this one with this form because it is greater or equal to. Why closed interval? Again I'm repeating, because the solution is greater or equal to, that's why, or less or equal to if it is, we are going to use closed parentheses. And the last part, solution set, it's going to be for us here x such that x is element of the solution interval, it's going to be 1 here. That's why only one interval I'm writing, and I'm going to finish my solution. For this question we are going to firstly multiply the term, and I'm going to collect the terms to one side for the question B. Here x squared plus 2x, it's going to be minus 35 is greater than 0. Again the sign is positive. First I'm going to factorize this one, x squared minus plus 2x minus 35. Let me try when it's equal to 0 what it should be. X, 5 and 7 are the roots. Plus 7 it's going to be minus 5 because the sum is 2. Product is minus 35. Then x minus 5 times x plus 7 is going to be equal to 0. x1 is equal to 5 and x2 is equal to minus 7. It's going to be, again if I draw the table here for the quadratic equation, x squared plus 2x minus 35, here minus 35, the roots are minus 7 and 5. Function continues from minus infinity till infinity. Okay, then the roots are here, the sign of the x squared is plus, that's why this sign is plus, minus and plus. If it is not, if you remember, I'm repeating for all questions, if it is minus, plus, and minus it's going to be. Then I'm looking for greater than 0 intervals. This is the greater than 0 interval, so these intervals I'm going to take. I'm going to shade firstly that intervals, Then I'm going to write the solution set with respect to these intervals. Okay, this is the shaded interval that I want to. And then the solutions are minus infinity, and minus 7, and 5 to infinity. It's going to be infinity sides are always open, and minus 7 and 5 sides also they are open. So the solution set x such that x is element of minus infinity minus 7 union 5 to infinity. It's going to be. For these type of questions, now we studied this one when we were learning the delta form. When delta is greater than 0 or delta is less than 0, and now we are going to solve this type of question. Consider the equation x squared minus 2 times m plus 1 x plus 1 is equal to 0, and for which values of m does the equation have two different solutions. If you remember, we were learning this one by when we were solving delta questions. Delta is greater than 0, delta is equal to 0, delta was less than 0. When delta is greater than 0, two different solutions there was. So I'm going to check the case delta is greater than 0. If delta is equal to 0 to double root and same root, it means when delta is less than 0, no real root, if you remember from the previous lessons. Okay, quickly I repeat this part, then I'm continuing with this one. So if it has two different solutions, it means that delta must be greater than 0, which means b squared minus 4ac must be greater than 0. Actually, this part is our quadratic equation. It's going to be, because b is equal to minus 2 times m plus 1 square minus 4 times a is equal to 1 and c is equal to 1 here, a is equal to 1 and c is equal to 1 here, and this is the also b. It's going to be, so when you get the square, it's going to be minus 2 squared, which is equal to 4, m plus 1 squared, it's going to be, and it's equal to minus 4, it's going to be greater than 0. Here it's going to be equal to 4 times m squared plus 2m plus 1 minus 4, it's going to be greater than 0, so 4m squared plus 8m plus 4 minus 4 is going to be greater than 0. So 4m squared plus 8m is going to be greater than 0. Then I'm going to solve this one as a quadratic inequality. This is quadratic inequality. Firstly, I need to find the roots. 4m squared plus 8m, when it's equal to 0, we are finding the roots. 4 times m, I get 4m parentheses, m plus 2, it's going to be 4 times m, 4m squared, 4m times 2 is equal to 8m, it's going to be. So this factorization is true. I also isolate the common factor. 4m is equal to 0, m is equal to 0, and the second one, m1, this is m1, I can say, this is m2, m2 is equal to minus 2, it's going to be. So the table for the minus infinity and infinity side, the roots are minus 2 and 0 for the function 4m squared plus 8m. And as you see here, the first sign is 4 and the number is 4, the sign is plus, that's why I have written here plus, then minus, then plus it's going to be. And it is asking for the plus intervals, which means I'm going to shade this side, I'm going to shade this side and this side. Then for which values of m it says, so we are looking for m values, and solution set, it's going to be m such that m is element of minus infinity minus 2. This is also open, it's going to be, because it is greater than 0 case or less than 0, it's both open, union to 0 to, sorry, this number was 0, here it is 0 to infinity, it's going to be. So this is the m value of the question.